Good day, everyone. You're welcome to my YouTube channel, Everything Medical. On today's video, we shall be appreciating the embryology of the bronchi and the lungs. That is the development of the bronchi and the lungs. If you are coming across to my channel the first time, please subscribe, like, and also share our video. Also comment so that it will get to wider reach, right? Now, let's dive into the video. I've done video on the overview of the respiratory system. I've done video on the development of the trachea and the larynx. And here is the development of the bronchi and the lungs. Why we'll be talking about the bronchi and the lungs is because they both evolved from a single origin, that is the bronchial board, right? Now, these are the diagrams that we shall be using to depict the development of the bronchi and the lungs. These diagrams you are seeing here are the various stages of the development of the bronchi, right? This diagram, this first one, begins to develop from the 4th week of the IUL, this 5th week. This here is from 6th week of the IUL, that is intrauterine life or life in the womb. Why this is already matured bronchi, right? Which develop from the 7th IUL, 7th week of IUL. Why these diagrams here you are seeing on this side depict the 4 cardinal stages of the maturation of the lungs. Yes, the first one begins to develop from the 5th week to 16th week of IUL. We call it the first stage of lung maturation, right? Which is called the pseudoglandular stage. Why this here begins to develop from the 16th week to 26th week of IUL. We call it the canalicular stage or period of lung development. Why here begins to develop from 26th week of IUL to birth. We call it the saccular stage, or the terminal sac stage of lung development. Why this diagram here depict the last stage of the lung development? Because that is where the mature alveoli form, right? So it begins to develop from 8 months after birth, 8 months after birth to 8 years, right? So alveoli begins to mature properly from 8 months to 8 years after birth, right? So to tell you that the lungs is a vital structure, it is a compassionate organ, right? Now, before we proceed with this video, I'm going to kind of do a flashback on how the origin of what that led to the formation of the bronchi and the lungs came about, right? Which is the bronchial board. The bronchial board. Bronchial board, right? You have to understand that the major origin where the respiratory structures, be it the respiratory zone and the congenital zone, evolve from is the respiratory diverticulum or the laryngotracheal diverticulum, right? Now, this is the respiratory diverticulum. As the respiratory diverticulum enters the thoracic cavity, right? It bifurcates into 2 structures. It becomes bifid to bifurcate into 2 structures, which is the right and left bronchi and lung board, right? As it enters the thoracic cavity, because this this respiratory diverticulum evolved from the foregut, right? Now, once it enters the thoracic cavity, it becomes bifid and bifurcates into two right and left bronchi and the lung board, right? Bronchi and lung board, right and left bronchial lung board, because there are two, right and left bronchial lung board. Now, these two structures have different fates. The lung board invaginates into the pericardoperitoneal canal to form the right and left pleural cavity, which is the sac-like sheath that covers the lobes of the lungs, right? While the bronchial board does what? Forms the bronchi and the lung parenchyma. The bronchi forms the whole bronchial structure, while the lung parenchyma, which evolved from the bronchial tree, forms the lungs. That is how it works, right? Now, here are the right and left bronchial board. Recall that the lung board is quite different, although it evolved from the same origin, that is the respiratory diverticulum, as it enters the thoracic cavity. The lung board, as I've said earlier, that it invaginates into the pericardoperitoneal canal to form the right and left pleural cavity, while the bronchial board forms the bronchi and the lung parenchyma, right? Now, the bronchi or the bronchial board, I mean to say, forms what we call the principal bronchus. It forms the principal bronchus. Principal bronchus. However, two divisions from the caudal aspect of the respiratory diverticulum forms the right and left principal bronchi. Right? Now, here, this is the left principal bronchi, left principal bronchi, while this is the right principal bronchi, right principal bronchi. The right principal bronchi is more larger. It is more larger and bigger, and also lie in the midline with the trachea, right? The right principal bronchi is larger compared to the left principal bronchi, and it is said to be oriented in the midline with the trachea. That is why the right principal bronchi is more vulnerable to pathogens, although the relationship or the embryonic relationship that made the right principal bronchi to be more bigger and align on the midline with the trachea ceases or persists after birth. That relationship only happens in fetal life. It does not happen in adult life. That means once the baby or the fetus is being given birth to, that relationship does not work. It persists once the baby is being given birth, right? So that is how it works. Now, the principal bronchus develop into or become subdivided to form the secondary bronchus, right? The secondary bronchus. So we have the bronchi board, which forms the principal bronchus, which give rise to right and left principal bronchi, right and left principal bronchi. Now, the principal bronchus give rise to the secondary bronchi. Secondary bronchi, right? Okay, this secondary bronchi is further subdivided to form three structures respectively. We have the lobar bronchi, the segmental bronchi, and the intersegmental bronchi, right? So we have the lobar bronchi, the segmental bronchi, and intersegmental bronchi. These are the structures that is subdivided from the secondary bronchi. Now, on the right side of the lungs, which is this side, the right side of the lungs, the superior lobar bronchi, supply to the superior lobe of the lungs, right? Now, here is the superior lobar bronchi, or the upper lobar bronchi. The upper lobar bronchi supply to the superior lobe of the lungs. Here is the superior lobe of the lungs, right? Supplies to the superior lobe of the lungs. Why the inferior lobar bronchi here? This is the inferior lobar bronchi. Inferior lobar bronchi. Inferior lobar bronchi is subdivided to form the middle and lower lobar bronchi, right? To form the middle lobar bronchi and lower lobar bronchi. Then the middle lobar bronchi supply to the middle lobe of the lungs, which is here, the middle lobe of the lungs, while the lower lobar bronchi supply to the inferior lobe of the lungs. That is to say that the right principal bronchi give rise to the upper lobar bronchi, the middle lobar bronchi, and the lower lobar bronchi, which supply to the superior lobe of the lungs, the middle lobe of the lungs, and the inferior lobe of the lungs. You can see these structures, right? You can see it. Look at them here. We supply to these lobes of the lungs. Now, on the left side of the lungs, the left principal bronchi give rise to the upper lobar bronchi of the left side of the lungs and the lower lobar bronchi of the left side of the lungs, right? Now we have the upper lobar bronchi of left lung and lower lobar bronchi of left lung. This upper lobar bronchi then supply to the superior lobe of the left lung, right? The lower lobar bronchi also supply to the inferior lobe of the lungs. So that is how it works. So we have the superior lobe of the lungs. We also have the superior lobe of the lungs. So these are how the bronchi evolve. Now, continuously, each of the lobar bronchi undergoes progressive branches. It undergoes progressive branches to form 10 segmental bronchi. So, in summary, each of the lobar bronchi undergoes progressive branches to form 10 segmental bronchi in each of the lungs. That means we have 10 segmental bronchi here. We have 10 segmental bronchi here as a result of the progressive branches of the lobar bronchi. Because after the lobar bronchi, we have the segmental bronchi, right? Now, the segmental bronchi is 10. It is 10 on each side of the lungs. It begins to form from the 7th week of IUL. 7th week of IUL, intrauterine life. Now, each of these segmental bronchi and the surrounding mass of the mesenchyme forms the bronchopulmonary segment. Yes, that is the major essence. It forms the what? The bronchopulmonary segment, right? Because the 10 segmental bronchi and the surrounding mass of mesenchyme combines together to form the bronchopulmonary segment. Now, there are the various divisions of the bronchopulmonary segment, that is the bronchopulmonary segment, BPS. The division and subdivisions of this structure, that is the BPS, the bronchopulmonary segment, forms the distal part of the bronchial tree. It forms the distal part of the bronchial tree, which constitute the bronchiole, the respiratory bronchiole, the alveolar duct, and the alveoli. That is the major respiratory zone of the lungs, right? So you can see how the tree is going. First is from the lobar bronchi, we get to the 10 segmental bronchi. From there, the masses that surround the segmental bronchi forms the bronchopulmonary segment. Now, this structure, BPS, then forms the distal part of the bronchial tree, which constitute the bronchiolus, the respiratory bronchiolus, and also alveolar duct and alveoli. Recall that the alveoli is where gaseous exchange occur, because there is presence of the type 1 pneumocyte and type 2 pneumocyte. As we proceed, we'll get to discuss these compassionate cells, which is responsible for gaseous exchange and secretion of the surfactant, right? Now, this BPS is so essential because it is what that forms the distal part of the bronchial tree, which constitute the structures of the respiratory zone, right? Now, the epithelial structure or epithelial lining of the respiratory diverticulum has various subdivisions, which forms the lining epithelium of the bronchial tree, right? However, other elements that is found on the bronchial tree, such as the smooth muscles, the connective tissues, and the cartilages, develop from the surrounding splanchnic mesoderm. That is an important thing you should note about, because it is not all the structures that evolve from the lining that give rise to the respiratory structures. The smooth muscles of the respiratory system, the cartilages, and also the connective tissues evolve from the surrounding splanchnic mesoderm. Surrounding splanchnic mesoderm, right? Splanchnic mesoderm, right? This is This is what that give rise to the connective tissues, the smooth muscles, and the cartilages of the bronchial tree, right? Now, this splanchnic mesoderm also form or contribute to the formation of the connective tissues and the capillaries of the lungs, right? So that is all about the development of the bronchi. Now let's dive into the development of the lungs, right? Lungs development. Formation of lungs. The lungs is formed from the lung parenchyma, right? It evolved from the lung parenchyma or parenchyma of the lungs. Recall that this lung parenchyma is formed from the bronchial board, because the bronchial board give rise to the bronchi, which we have just discussed, and also the lung parenchyma. The middle lobe of right lung, the inferior, the superior lobe of right lung, superior lobe of right lung. Let's discuss the formation of the lung parenchyma, which give rise to the lungs, right? This lung parenchyma is formed from the bronchial tree as a result of the further subdivision of the lobar lobe, the lobar bronchi per se, right? Now, the developing lung parenchyma from the bronchial tree is separated by the mesoderm, right? Is separated by the mesoderm, right? Recall that this lung parenchyma occurs as a result of the subdivision of the lobar bronchi from the bronchial tree, right? And the lung parenchyma is separated from the bronchial tree by the mesoderm. And the mesoderm also constitutes to the development of the tissues of the lungs. That is the connective tissues of the lungs, and also the capillaries, right? However, it also helps to separate the structures of the lungs. That is the pleura of the lungs, because the pleura of the lungs is that sac-like sheet that encloses the surface of the lung lobe, right? So that is all about the formation of the lungs. It develop from the lung parenchyma, and lung parenchyma occurs as a result of the further subdivision of the bronchial tree from the lobar bronchi, which is separated from the bronchial tree by the mesoderm, right? So let's discuss the maturation of the lungs, because lungs matures. We have 4 stages of lung maturation. What we just discussed on the lung parenchyma is the origin of how lung evolved from the bronchial tree. right? So maturation of the lungs. Maturation of the lungs. These are the diagrams that depict the 4 stages of lung maturation. The first stage is what we'll call the pseudoglandular stage, right? The pseudoglandular stage. First is pseudoglandular stage or period. Pseudoglandular stage or period, whichever way. While the second is the canalicular stage or period. Canalicular stage or period. The third stage is the terminal sac stage. Terminal sac stage. While the fourth stage is the alveolar stage. Alveolar stage. The alveolar stage, right? Let's digress them one by one. Now, the pseudoglandular stage, you can see it here. We have 4 structures here, right? Those 4 structures depict the 4 stages of lung maturation, right? Now, this diagram depicts the pseudoglandular stage. It is that stage of the lungs that resembles the histological appearance of the exocrine gland. Now, the bronchioles is further divided into terminal bronchi. Here is the bronchiole. The bronchiole is further divided into terminal bronchi. The bronchioles is further divided into terminal bronchi. This is the 2 terminal bronchi. Terminal bronchi, right? And recall that the elements of the conducting zone of the lungs, that is the bronchi, the bronchiolus, and everything usually form in this stage. But the element that forms the respiratory zone of the lungs, such as the respiratory bronchi, that is the respiratory bronchiolus, the alveolar duct, the alveolar sac, and the alveoli are not formed in this stage. So any fetus that is being given birth to in this stage of lung formation will not survive because the respiratory zone has not been fully formed, right? So the main structure that forms in this stage is those structures that forms the conducting zone of the lungs, which end in terminal bronchi. But those structures or those elements that forms the respiratory zone of the lungs, such as the respiratory bronchiolus, the alveolar duct, and the alveoli, are not formed. However, any fetus that is being given birth to in this stage of lung formation will not survive because the gaseous exchange structures has not been formed, right? So that is all about the pseudoglandular stage of the lungs, of the lung maturation. Let's quickly go to the next one. We have the canalicular stage. Now, the canalicular stage is here. Recall that these are the capillary blood vessels. That is what we call the lung capillaries, right? They are the lung capillaries, which usually form plexus to the terminal sacs or the primitive alveoli. Now, this diagram here depicts the canalicular stage of the lung formation. Now, on this lung formation stage, the terminal bronchi usually dilate and become further subdivided to form the respiratory bronchiole, right? Here is the respiratory bronchiole. Respiratory bronchiole. Which is formed as a result of the dilation of the terminal bronchi, right? Recall that these cells you are seeing here are the cuboidal cells, right? They are the cuboidal cells. Cuboidal cells or cuboidal epithelium, whichever one. You can call it cuboidal epithelium or the cuboidal cells, right? Now, the respiratory bronchiole is also further subdivided to form the alveolar duct. The alveolar duct, right? These are the alveolar duct. These are the alveolar duct, which is formed as a result of the further subdivision of the respiratory bronchiole, right? So these are the alveolar ducts. The alveolar duct. Now, in this stage, there are a few formation of the terminal sac or the primitive alveoli. So any fetus that is being given birth to in this stage of lung formation will rarely survive, because the baby will be in ICU, intensive care unit, right? It has to be in a pediatric intensive care unit, because as you can see, there are few presence of the primitive alveoli, that is the terminal sacs, in which where the gaseous exchange takes place, right? So you can see that the chances of baby that is being given birth to in this stage of lung formation to survive is snappy. For this stage, the baby cannot survive, but in this stage, the fetus survival is snappy. It has to be in intensive care unit, right? So that is all about the canalicular stage of the lung formation. Although one of the cardinal events that happens in this stage of lung formation is that the lung structures are fully vascularized. The lung structures are what? Fully vascularized, right? You can see that all these structures are the capillary structures of the lungs. That is the lung capillaries, right? They are the lung capillaries. The lung capillaries. The lung capillaries. They are the lung capillaries, right? Now, let's quickly look at the terminal sac stage. The terminal sac stage or the saccular stage of the lung formation. It is a stage whereby there is large number formation of the terminal sacs, that is the primitive alveoli, right? You can see it here. This is the stage here. This structure depicts what we call the terminal sac stage. It is a stage whereby there is large number of formation of the primitive alveoli, which can be called the terminal sacs, right? Now, in this stage also, the lung capillaries begin to proliferate and form plexus which surrounds the terminal sacs. They form plexus that surrounds the what? The terminal sacs, right? Now, the epithelial wall of the terminal sacs become more thinner. It becomes very thinner, thereby allowing those capillaries to bulge into it, right? By the virtue of doing that, there is usually a contact between the epithelial cell or the epithelium and the endothelial cells. Once they come in contact, they form what we call the blood-air barrier. The blood-air barrier is an important structure. The blood-air barrier. Blood-air barrier. The blood-air barrier permits adequate gaseous exchange for the lungs. It permits adequate gaseous exchange for the lungs, right? Now, the terminal sacs, that is the primitive alveoli, is lined by an endodermal squamous cell called the type 1 alveolar epithelial cell, or the type 1 pneumocyte, right? Now watch. You can see that all these cells are cuboidal cells. These are cuboidal cells, right? All of them are cuboidal cells, except these ones. These ones are the endodermal squamous cell, flat cell, called the type 1 pneumocyte, or type 1 alveolar epithelial cell, right? Now, this is the first cell that evolved, right? However, the lungs also have other cells that are scattered around, which is called the type 2 pneumocyte. The type 2 pneumocyte, or type 2 alveolar epithelial cell, is responsible for the secretion of the surfactant, right? And recall that the deficiency of surfactant leads to respiratory distress syndrome or highly membrane disease, right? Now, the type 1 pneumocyte, which is the first cell that evolved, right, is responsible for gaseous exchange, right? That is the cell that is responsible for gaseous exchange in the alveoli. Type 1 pneumocyte is essential for gaseous exchange in the alveoli. Recall that the alveoli is the functional unit of the lungs, right? Now, this is alveoli. Alveoli. This is alveoli. This is alveoli. This is alveoli. Or we call it the terminal sacs. They are the terminal sacs, right? Or the alveoli. Now you can see that the cell lies on it. This cell is called the type 1 pneumocyte. It's a flat cell, endodermal squamous cell, which is responsible for gaseous exchange. That is why the alveoli is the functional unit of the lungs, because this is where the gaseous exchange occurs. And they are being wound around by the places of capillaries. So this is what we call type 1 pneumocyte. Type 1 pneumocyte. Recall that I said previously that this is alveoli, which is being surrounded by type 1 pneumocyte, which is the cell that is responsible for gaseous exchange, right? The blood-air barrier, which is being formed or being established by the direct contact of the epithelia and the endodermal cells, is responsible to permit adequate gaseous exchange, right? Whereas the type 1 pneumocyte is the main cell that is responsible for gaseous exchange, because you can see that it is found in the alveoli. And that is why alveoli is the primary unit of the lungs where gaseous exchange occurs, because of the type 1 pneumocyte, followed by the type 2 pneumocyte, which is responsible for the secretion of surfactant, right? So that is how it works. So all these things are the lung capillaries. They are the lung capillaries. Now, let's look into the alveolar stage. This alveolar stage is a stage for the last stage of lung formation, right? So it is in this stage that we have mature alveoli. Although there's an alveoli here on the terminal sac stage, right? But here is where it gets matured. And this maturity begins from 8 months after birth to 8 years. That is the range that the alveoli fully mature, because the terminal bronchi and the respiratory bronchiolus became subdivided to form the alveolar duct. The alveolar duct then forms what we call the mature alveoli, right? So here is the mature alveoli. All these are the mature alveoli because they are being lined by the type 1 pneumocyte. So mature alveoli. Mature alveoli, right? You can see the cell, type 1 pneumocyte. They are so flat. We call them the endodermal squamous cell. And a squamous cell is a flat cell, right? So they lie on the alveoli. All these are mature alveoli. Now, you can see that these cells are round. They are called the type 2 pneumocyte because type 2 pneumocytes are round cells, while type 1 pneumocytes are flat cells, endodermal squamous cell, right? So this is type 2 pneumocyte. Type 2 pneumocyte. All these are capillaries for gaseous exchange. They are the long capillaries. All of them are long capillaries that wind on the terminal sacs or the primitive alveoli, which then become the mature alveoli. Recall that the main reason that alveoli is responsible for gaseous exchange is because of the type 1 pneumocyte. I said previously that the type 2 pneumocyte is responsible for the secretion of surfactant, and deficiency of surfactant leads to respiratory distress syndrome, which can be called hyaline membrane disease, right? That is all about the maturity of the lung structure. Now we have so many embryological correlation of lung and bronchial development. Number one is the medico-legal importance of the newborn lung. Medico-legal importance of the newborn lung is a condition whereby we use the lung to assess if the baby was giving birth alive or the baby was giving birth and is not alive, right? Now, you can see that when a baby is being given birth alive, there is air in the lungs. There will be air present in the lungs, right? And when you place the lungs on top of water, it will float, it will not sink because there's air inside. And when you touch the lungs, it will crepitate. It crepitate on touch on pressure to tell you that yes, the baby was giving birth alive. But when you bring the lung of a baby that was not giving birth alive, when you place it on top of water, it will sink because the lungs contains fluid. It has no air inside because the baby was giving birth and is not alive. That is maybe is still birth or stillborn, right? Whereby the baby was giving birth and is not alive. When you touch the lungs of a baby that was giving birth and is not alive, the lungs does not crepitate on touch and it sink when you place it on top of water because the lungs contains fluid, not air, right? That's what we mean by medico-legal importance of the newborn lung. We use it to assess if the baby was giving birth alive or the baby was not giving birth alive. The next one is respiratory distress syndrome, which can be called hyaline membrane disease. It's a condition whereby there's deficiency of the surfactant. Maybe type 2 pneumocyte is being malfunctioned or being deficient, right? The next one is the agenesis of the lungs, which is mainly occur as a result of the deficiency of the bronchial bud, because if the bronchial bud is not formed, lung will not be formed as well. We have unilateral agenesis of the lungs and bilateral agenesis of the lungs. If it's unilateral, that means one bronchial bud is not formed. But if it's bilateral, that means two bronchial bud was not formed. So we have agenesis of the lungs, which simply means non-formation of the lungs. Imagine when the lung is not being formed in the system. the fetus can survive, right? The next one is hypoplasia of the lung. It's a condition whereby the lungs is underdeveloped. Hypoplasia of the lungs is an underdevelopment of the lungs, right? Which is mainly caused by the congenital diaphragmatic hernia. Congenital diaphragmatic hernia is a condition whereby the structures of the abdomen pushes up to the thoracic space, thereby occupying the space that the lungs would have been formed, right? That is why one of the criteria for lung formation is adequate thoracic space for the lung growth. So if there is a congenital diaphragmatic state of the diaphragm, that is hernia, whereby the diaphragm protrudes upward towards the thoracic space, thereby occupying the space that lungs will have been formed. That means there will be hypoplasia of the lungs. The lungs will become too small and it will be what? Underdeveloped, right? The next one is the abnormal lobe of the lungs. Abnormal lobe of the lungs. Imagine if there are so many lobes of the lungs, or there are few lobes of the lungs occurring from the deficiency of the lobar bronchi coming from the principal bronchi of the lungs. The next clinical condition of the lungs is the azygous lobe of the lungs, which can be called the lobe of Risberg, right? The lobe of Risberg. Azygous lobe of the lungs can be called the lobe of Risberg. We have other clinical correlation of the lungs, where we have the atopic lung lobe. It's a condition whereby the lung evolved from the bronchi, or it evolved from the trachea also. So those are the clinical condition that is associated with the development of the bronchi and the lungs. I believe you enjoy the class, ranging from the ranging from the overview of the formation of the bronchial bud from the respiratory diverticulum till the clinical condition. Thanks so much for staying to the end of this class. I really appreciate it.